So throughout your time with Geant4, you may see some things which seem a bit strange to you, even if you've done some previous C++ in other labs or subjects. So even if you've done a little bit of C++, this declaration or code here might seem a bit strange. We've got G4 box asterisk world equals new G4 box blah blah blah, or probably much less strange, but different than what you normally see is this G4 double world equals 100 times centimeters. So throughout the next few videos, I want to give a bit of context to what this syntax is, or what this syntax is. So let's just do a bit of fundamental C++. So let's just do a regular C++ program. So let's start with our regular iostream using namespace standard main. So let's say we want to calculate the area of a rectangle. So we want a length and a width variable. So hopefully you already know about data types in C++. So unlike something like MATLAB, you can't just go variable equals 27 or something like that. You have to specify what the type of data that a variable will be holding. So in this case, we have to tell the compiler that it'll be holding data type of double, and so let's also our width, and then finally our area. So let's just set our length to 3. Let's say our width is equal to 5. Then our area equals length times our width. And let's just print that out to the screen. So area is equal to area. So let's just compile that quickly. So my name is foo.cc, and let's output foo.out. Oh. L instead of O, very good. So just run that, and we got an area of 15. So just looking a bit with this double length. So the reason why we need to specify the type of data that it'll be holding is so the compiler knows before the program actually runs of how much memory it needs to allocate for this program to run it. So if we were to picture this as some random memory chunks in our system, then if each block is representing 1 byte, so we've got 10 bytes of data here, and another 10 blocks of another 10 bytes of memory here. So in total we've got 20 bytes of data. So if we just quickly look at how much memory a double uses, so if we just go use the size of command and go double, that will tell us how much memory the variable uses up. So it uses 8 bytes of data. So I'll just get rid of that now, that we won't use it again. So when this program is being compiled, when it gets to this double in area, it will allocate this 8 bytes of data. 8 bytes of data to the memory, and they'll be holding this area variable. So let's say this 8 blocks of data is where our area lives in the system memory. So in C++, you can actually return the address of where data is being held. So if we wanted, we could return or we could retrieve the memory address of this block here. So the way we do that is with pointers. So how that works is, I'll just show you. So we've got pointer area. So what this double asterisk means is the variable here is a variable pointer area, and what it is it holds the memory. What this variable called pointer area is, it holds the memory address of a data type of double. So just to point out, you can write either of these two syntaxes when you declare a pointer variable, but I just prefer this type just because it's a bit more distinguishing my point of view. Like you're saying double asterisk, so this is a variable type rather than if you had this. So this comes down to personal preference, but you can do either of those two. And similarly, if I had an integer, let's just say point int. So what this would be doing is it would point to the address of some integer. So let's say if I had an integer, and let's just say it was count, and let's say, for instance, this count was held in this address here. So in this memory address, it was taking up these chunks and starting here. So this pointer, assuming I set it up correctly, let's say it's being pointed here. So back to just the double pointer variable. So I haven't actually given it a value. I've just declared that this variable pointer area, that it will hold memory addresses of memory which holds a double quantity, like a double variable. So if I actually want to give the pointer a value, I use what is called the address operator, and that's just the ampersand symbol or the and symbol. And what you do is you just put it in front of your variable which you want to point to. So in this case, I just give it the area. So this just means, give me the memory address where this variable starts. So if this were our area variable was stored, then the memory address of area would return this starting address here. So it returns the starting address, and that's because when you declare the pointer, so in case pointer area, we tell it that it's storing a double or pointing to a double variable. So it knows that it will take up 8 chunks of memory. So since it already knows the starting memory address, it would work out the range of that whole memory because it knows it's storing a double. So let's just spit out the memory address. So if I just go the memory of area, memory address of area is equal to pointer area. Let's save that and compile it. So you get some random junk here. So that's just because, the memory is still in hexadecimal or something. So it'll just be some random memory address out of all the gigabytes of memory. So, it's nothing nice. You won't get saying like, 10 or something like that. You just get some random junk looking number. And so once you've got a pointer, so like pointer area, once you've got it pointing to some address in memory. So in this case, it just is one block memory address. You can actually change the value which this block of memory is storing. So to do that, what we do is we use the indirection operator. So what the syntax for that is, we go pointer, sorry, so this asterisk is what we call the indirection operator. So if we put that in front of a pointer variable, that means pretty much change or assign whatever value to the memory address. So if we went 49, for instance, and if we save that and we just print that out twice, compile that and run it, then you see the area was 49, and then what we did was we changed the memory address. So what we did is we had our area being stored in this chunk here. Then we got its memory address here, its starting memory address, and once we had that memory address, we were able to change the value stored in this chunk of data, in this chunk of memory, by using the pointer. So the concepts of pointers are quite new and complicated area or topic, and you don't have to really worry about any of this for your time with Geant4, but just so we can work towards the context of what we're actually doing with when we see something like this. So if you Google what's the point of using pointers in programming, you'll get a load of sometimes weird and complicated questions, but one of the simpler ways to think of them as an advantage of, if we had hyperlinks and we had, the same hyperlink lots of places throughout multiple websites, and this same hyperlink all went to the one website. If we were able to just change that one website, then all the other hyperlinks which were using that one website would also be updated. So in a way, if you had multiple things relying on this one variable or data held here, then with pointers you can do a bit of tricky manipulation. But again, you don't need to worry about any of that weird tricky stuff. Mostly just trying to get to the syntax for you. And one final thing with pointers before I move on is often when you're playing with a program, and if you don't know how much memory you're going to need until you're actually running it, so in that case the compiler can't allocate how much memory it needs. So in this case, we're telling it, I'll be using these variable doubles, and it knows it's 8 bytes each, so it can decide how much memory to allocate because it's just doing one thing. But if instead we weren't sure how much memory we're going to use, so for instance, if we were going to shoot a particle in some matter, then it might create a billion particles when that one particle goes through some volume, or it might just create no particles whatsoever. Or if you think of more everyday sort of scenario. Let's say, you're loading some database file, but you didn't know how many entries were in that database file, so you allocate a lot of memory for the program to use when it runs. So in C++, if you're not sure how much memory you're going to use and you just want to give the program a big chunk of memory to play with, then what you do is use the new operator, well, not the new operator, but the new command. So if we had a pointer, let's say we'll point to double. So what we'd do is something like double and say, I'll call it owl for allocate. And what we'll do was new double. So what this would be saying is, I want to store a lot of double values. Well, maybe not a lot. I don't know how much data I will be using in my program. So can you just give me a lot of memory to play with? So that's how in C++ we tell the compiler to allocate me a big chunk of memory to play with. So that's all I'll talk about pointers for quite a while, and then in the next video I'll just talk about functions, and then finally after that we'll talk about classes / objects, and then finally we'll get back to this one, syntax.